Okay, so my name is Arjan Times, and I'll be presenting this session about GlassFish at Eclipse, and we'll look a little bit at Jakarta EE10 in relation to that. So you can reach me at Twitter on the names that are listed there. Okay, so let's go to my bio. So let me see if this comes across. Oh. There we go, it's a bit slow. The connection here, I'm afraid. Wait a little bit for this. So I'm a 40 years Dutch developer from the Amsterdam region. Very nice city, by the way. So I've got a Master of Science degree in computer science from the University of Leiden. And I'm involved with the Omnifaces projects and the Piranha Cloud project. Okay, I was previously a JSF, JSO 372 expert group member, and I served on the security API as well. So I'm the project lead of several projects at Eclipse. So mostly Jakarta Faces, the security projects. It includes Jakarta security itself, authentication, authorization, what have you. And recently I've been maintaining and releasing GlassFish quite a bit. Hence I'm giving this presentation. So I'm also the co-author of 3 books. So the Definite Guide to JSF in Java EE 8. We're going to have a update of that available soon. Then Pro CDI 2 in Java EE 8 as well. And coming soon will be the Definite Guide to Jakarta EE security. All right, so let's take a look at the agenda. So what we're going to talk about today. So we're first going to do some basic concepts. Then we're going to look at the history of GlassFish, look at some of the recent developments, things that have been going on at Eclipse mainly. Then we're going to take a look at the things that go a little bit beyond the pure server. There's the ecosystem, the family of GlassFish. And we'll be looking at the roadmap of GlassFish 7 specifically, and particularly in relation to Jakarta EE 10. Okay, so let's go to the next slide over here. So let's wait until it shows up. It's low here. Okay, so GlassFish, the basic concepts, let's go quickly through them in case people don't entirely know what GlassFish is about. So GlassFish is first and foremost an open source project. It's dual license, so it has the Eclipse public license, the EPL, and it's a dual license with the GPL with ClassPath exception. And people can choose which one they use. The project is owned and governed by the Eclipse Foundation, so not by a commercial entity. And that makes it like a true open source project. So GlassFish is also about Jakarta EE, so perhaps not surprisingly, giving the topic of this conference. So Jakarta EE, I guess everybody knows what this is, but just to be sure, it's a full stack web application development framework. It provides APIs for a lot of things that a lot of applications use. So persistence, transactions, HTTP handling, servlets, do that, MVC, security. So it covers basically the entire spectrum of what most applications need. So one thing that's specific about Jakarta EE, especially when you contrast it to other frameworks which might offer similar functionality, is that Jakarta EE provides a very strict separation between the API and the implementation. So in other frameworks, that might be the case as well, that you have an API, you have an implementation code, but it might not be so strictly separated. So the the programming service of the things you see is quite huge. So in Jakarta EE, this is like really cleanly separated. So it also means that the API can be implemented by multiple parties, multiple vendors. There's a collaborative effort on the API, so all parties contribute to that. But implementation is specific to a vendor. So even though they're sometimes shared, as we'll see as we go along, particularly they are specific for the vendor. Okay, so then the third concept associated with GlassFish is the fact that it's an application server. So what is an application server? So this is essentially a piece of software that supports deployments. So you can install, you can remove an application. It typically has the ability to run multiple applications at the same time. And there's like a weak amount of isolation between them. So they're somewhat isolated, but not really strongly. So they typically include an HTTP server. So they're listening to various ports, mostly for all HTTP, but it could be some other things like Corba. And it typically supports clustering and some management of the global resources that are within the application and within the server. So this kind of defines what an application server is. So it's true that recently for the past couple of years, the combination of Docker and Kubernetes, it partially replaces the concept of an application server. So it essentially split out the application target and the clustering bits, and it puts the APIs in the hands of the engineers. So some say, okay, the application server concept might be antiquated, it might not be that relevant anymore. Well, it's not exactly the case. So even within a Docker environment, Docker makes it like really easy to just deploy an application server with a single application. So then people might ask, why do you want an application server in the first place? Why not just combine the two in one logical unit? Well, the thing is that an application server in Docker can occupy one layer of the Docker image, and the application can quite easily occupy the top layer. So you, even with a Docker deployment, where you deploy an application server, you still have this clean separation between the framework logic and your pure business logic. So the deployment can still be quite small. If you have a base image with the application server in it, and you just deploy a layer with say a var inside it. So other frameworks can do this to some degree, but it's not as easy. So in those things, it's quite common to have this, the libraries that you use and the business logic very tightly coupled. So you can separate them, but it's a bit more hassle. Okay, so now that we have covered the basic concepts, let's take a look at the history of GlassFish. So GlassFish goes back quite a long time. So essentially, the origins are all the way back in 1996. So that was the Kiva application server. Then a major milestone was reached in 2006 when the actual name GlassFish was introduced, or it was introduced a year prior, but that was the 1.0 release. And of course, a major milestone was the move to Eclipse in 2018. So this was basically due to Oracle having acquired Sun, and then they already had multiple application servers, and at some point they decided to transfer GlassFish and Java EE. Okay, so let's take a look at a few more details here. So when we look at the GlassFish history at the Kiva enterprise server, so Kiva was one of the first application servers on the scene. So there were some things that you could potentially classify as an application server before that. They were in C++. It's not exactly the same thing. Kiva was really one of the first on the scene. So they quite quickly grew. So they had like 100 employees. I think they had like 5 field offices. They raised about 40 million in capital investment. So they were quite rapidly growing. And it was quite a valuable market at the time, a valuable product in the market. So application servers were at the time between 25,000 and 35,000 per processor. I think it was depending on the operating system. So if you had Windows, it was a bit cheaper. If you had Unix, it was a bit more expensive for some reason. Okay, so now let's take a look at the next step there. So this happened when Netscape acquired Kiva. So this was around 1997. So they released the Netscape application servers, essentially Kiva, rebranded to Netscape, and the deal was then at the time around 180 million. So it would be approximately 300 million in current day dollars. So then Kiva Enterprise Server became the Netscape application server. Essentially the same thing as mentioned, rebranded and enhanced by the Netscape going forward. So then at some time in 1999, American Online acquired Netscape. So it's always a thing of one fish eating a smaller fish, and then the fish gets eaten by an even bigger fish. So that happens all the time. It happens here too. So Netscape acquired Kiva, and then American Online acquired Netscape. And at that point, American Online looked at this technology and they wanted to do a cooperation with Sun. So they were already running on a lot of Sun hardware, a lot of Sun servers. Sun was busy with the J2 EE specification, so they thought it was a good idea to set up an alliance. So this alliance was made, was formalized in March 1999, and the CTO was a guy named Bud Tribble. And interesting thing is here that he co-founded the Next together with Steve Jobs in 1985. So this was somebody who had like a long experience in this IT market. So at the time, Sun had also acquired a server called Net Dynamics, and they kind of planned to merge them in some way, and then have this common programming model between the two. That was J2 EE. So here we see one of the first businesses in the IT history where two completely separate servers were attempted to be united or had a common interface for all those complicated things they did, and that was the J2 EE specification. It didn't exist yet, but they were working on it. But then at some point things didn't quite work out. It's too complicated to merge them. So the actual plan to merge them were aborted, although they still used the J2 EE API. But Net Dynamics wasn't continued. It was everything was continued on the Netscape application server. Okay, so then in a somewhat confusing move, perhaps, the Netscape name was dropped, but this was changed into iPlanet. Kind of a generic name, actually. It's kind kind of signaled in the market that Netscape wasn't that important anymore. So everything related to the name and Netscape was done away with, and this kind of somewhat meaningless iPlanet name was introduced. So then in April 2000, the next server was the iPlanet, the iPlanet application server. So this was actually a continuous development of the Netscape application server. It supported NetDynamics APIs. So they had a lot of proprietary APIs, server-specific ones, which might be related to the number 5 being skipped. So they went from Netscape application server 4 to 6. But it might be because NetDynamics was at 5, and they're both being replaced by this new iPlanet application server. And specific for this server was that it was the very first one to be certified for this new released API specification suite called J2 EE, Java 2 Enterprise Edition. So the price was down to 5,000. So application servers were getting cheaper. So this was 2,500 to 3,500 before, and it still contained a number of C++ components. So it wasn't true in full Java yet. So it was somewhat of a messy install. So if you had a Windows installer, you had to install a separate naming server, I think, separate database, separate web front-end server, and they all had these different installers. It wasn't quite an elegant project yet. But yeah, it did worked, and it was the first to be J2 EE. I think at the time the consortium had like 1,100 engineers, but it also had like 40 projects. iPlanet wasn't the only server. There are a lot of other things inherited from Netscape and Sun, email servers, portal servers, quite a lot actually. Okay, so then we begin with the most significant point, I think, in the GlassFish history. That was the Sun1 application server. So the Sun1 application server was a direct successor to iPlanet. But it was mostly a major rewrite. So it wasn't directly a continuation of iPlanet. It's not totally clear how much code was carried over. So it was said that it was based on the existing RI, which is the reference implementation, the iPlanet web server, which was a separate product from the application server, and of course the by now well-known Tomcat 4. And particularly new here is that we had a free basic version. So it wasn't open source yet, but it was free. So the developers could use it without paying anything. I think the enterprise editions had some more features like clustering and more extended management. I'm not exactly sure. So it still had a small amount of C code. So you still had separate installers for the different operating systems. But it was mostly Java. And a very important thing, it's sitting on install. So the previous one was like quite messy with others, multiple installs. This was just a single one. You see here the S1 AS term, and that's one thing we still find back in current GlassFish. So there's a couple of key stores that use this term inside the application server source code of GlassFish, still being used. So here we have the most direct ancestor of GlassFish. Okay, so then about 1 or 2 years later, the name was renamed yet again. So we went from Kiva to Netscape, Application Server, iPlanet, Sun1, and in 2004 it was Sun Java System Application Server. So they kept changing the name like every year or 2 years. So they had multiple versions of this one. But particularly the 9.0 version is essentially GlassFish 1.0, which was open sourced in 2005 and released in 2006. And 9.1, that's essentially GlassFish 2. I think after 9.1, there were no more Sun Java application server releases. Okay, so then we get to the one of the most important releases in the history of GlassFish. That's GlassFish v3. So this was in December 2009, and that one happened just before the Oracle acquisition of Sun. So this one was like a major refactoring of the previous code base. And yeah, today we still see a lot of mentionings of v3 within the source code. You have entire packages that are v3. There's commented out code saying this is changed in v3. So this was like a major addition, major change to the GlassFish code base. So most influential was the modularity that happened. It was introduced via OCI, and a dependency injection system called HK2 was introduced. So this was in the development for like 2 years, and it handles a lot of services internally in GlassFish. So people who use Jersey might recognize this as well, since Jersey has HK2 too, and Drop Wizard uses HK2 as well, but otherwise it's not that much used. So GlassFish v3 was also the reference implementation for Java EE 6. So before GlassFish v3, it was a bit less official, so there were separate RI distributions used for reference purposes. GlassFish v3 was quite firmly designated to be the RI. Okay, so then in 2010, as mentioned, we have Oracle acquiring Sun. They still released a couple of GlassFish versions, 3.1 to 5. And 3.1 brought back a couple of high-end features like clustering and load balancing. They were temporarily removed from 3. So I think they were in 2, but with all the refactoring going on for 3, they were removed temporarily, and 3.1 under Oracle brought them back. So this was a major contribution there. But the following up versions, like it was a 3.1.1, there's a 4.1, and what have you. So they were all quite small in architectural updates. So they were mostly about new components for Jakarta EE, or Java EE at the time, I have to say. And it focused more on being the reference implementation. Architectural changes were almost non-existent. There were some bug fixes, but not really major new things outside Jakarta EE components. Okay, so then a major milestone is mentioned was in 2017, where Oracle announced the intention to transfer Java EE, including GlassFish, to the Eclipse Foundation. And I think the source code started transferring in early 2018. So the first source code drop was, I think, around January or something. So then, as part of the agreement with Oracle and the Eclipse Foundation, a verification build had to be released. So this happened in January 2019, approximately a year after. And this verification build was essentially equal to 5.0, but just built and tested and certified from all the transferred code. So this was a Java EE certified server. Then we went on to GlassFish 6, was released in December 2020, last year. This was Jakarta EE 9. Again, not many changes, but the namespace change was being done. So this was the reason to bump the major version. And then we had GlassFish 6.1 in 2021. It's not that long ago. This was just about the JDK 11 compatibility. So we planned to do that with Jakarta EE 9 before, but then we ran out of time and we really had to release something. So we postponed JDK 11 compatibility, and then in Jakarta EE 9.1 and GlassFish 6.1, we finally had to do that. Okay. So let's take a look at the recent web elements. So these are all the things that we did at the GlassFish, the Eclipse Foundation, I have to say, recently for GlassFish. So the highlights are that we kind of moved to a monthly cadence. It's not exactly monthly, it's more like 1.5 months, 1 month, 1 week, but it's about monthly. We also worked a lot on the JDK 11 and JDK 17 compatibility. So that's something we will talk about a bit next. And one of the highlights of the things we did centered around building and testing. Okay, so take a look at some of the versions that we released. So they're shown on the screen here. So we had, as you can see, approximately every month a release, and this was kind of important to us since previously it was thought that GlassFish was like really tied to the Jakarta EE releases. That was like quite difficult to release anything beyond the major Jakarta updates. But this proved to not be the case. So we could just release it after testing and it was just fine. So the Eclipse Foundation has infrastructure available to do CI testing, to do TCK testing, and it's essentially a few scripts, a few jobs that you run to build GlassFish, to test it, and to push it out to Mavis Central. So this really wasn't that hard. But yeah, before that, it wasn't proven yet that this was possible. But as you can see, it appears to be. And GlassFish is now on this approximately monthly cadence. So one of the things the team worked on was what we call true JDK 17 compatibility. So how we did that, we first made sure that the code built on JDK 17, and before that JDK 11, and it fell off of the slide, but it's supposed to say JDK 16. And this basically meant that the entire compile process, the entire build, had to succeed on JDK 17. So one of the things we did was try to ignore as few warnings as possible. So for each warning, you can typically do a quick fix. Like you can add opens, or you can do some reflective trick. But we really try to find the root cause for everything and not just do a quick hack. So one of the issues was that many of the Sun references, they were moved or made inaccessible, or they were just not there anymore in the JDK. And then typically we had to find public replacements for them. And so sometimes they weren't clear public replacements, or they were the replacements, but they were quite different from what GlassFish wanted to use, so we had to write new code for these. And of course, an important thing was update all the dependencies to JDK 17, and before that 11, and now to 18 for the current version that's in development. So this wasn't always easy too. So sometimes we had to nudge the maintainers of such dependencies a little bit because they weren't moving to 17 yet. And we had to sometimes provide a PR. So we did this for Felix, for example. And in a few occasions, we had to create a fork of a dependency and make that JDK 17 compatible ourselves. Of course, we don't want to fork too much, since that's extra maintenance overhead, but sometimes it's what you need to do. Okay, then an important thing was to run all tests on JDK 17. Make sure they all pass. So this includes all the embedded tests that are within GlassFish. So there's tests called Quick Look, there's a test called CDI All, there's Web JSP, there's a whole bunch of them. So we work hard to make them all pass, to make them all compatible, and if there were any issues found, to solve them. And to be absolutely sure, we also tested the build of a number of dependencies to see if they would compile to JDK 17. So the compiler is quite good at finding a lot of things. So if something does not compile on JDK 17, then chances are high it will not run really well in at runtime with JDK 17. So we did not compile all dependencies. So GlassFish has like 100 dependencies, but we did took a lot of the major ones. So Mahara, Soteria, Exusia, most of those things that we had experience with us, with ourselves. But this gave some more confidence that this was supported really well. Okay, so one thing that helped us as well was to test early and to test often. So for Jakarta EE 9.1, for example, the primary target was to be able to compile the code to JDK 11 and to be able to run it on that, obviously. But we had a stretch goal, and it was to compile and running on JDK 16.2. So that was reached with Jakarta 9.1. And for JDK 17 compatibility, we actually started before JDK 17 was released. So we tried this on the early EA builds, and then we incrementally worked towards the release of JDK 17. Because we had done the work before for JDK 16 compatibility, done the work before that on JDK 11, it wasn't that much more work. So this is what we mean with test early and often. If you postpone all this work until the end, say, okay, well, I'm going to skip from Java 8 right to JDK 17, you build up more work for yourself, and it might be even too much. You can't oversee the things that you need to do. But if you incrementally test all the time on the latest JDKs and fix issues rapidly and step by step, then it's quite doable. And now currently for JDK 18, which hasn't been released yet, but it did went into one of the last phases recently, we did the same thing. So we done a lot of things to make it compatible with JDK 18. So that's the version that's in development now, that's 6.2.4. Okay, so let's take a quick look at some of the things that we typically encountered for each JDK version. So this may also help people migrating their own applications to the different Java versions. So we had JDK 11, and this was mostly about modularity. So we had issues with split packages, packages in general. We had illegal reflections, so one package doing an reflective operation for other packets, and there were a lot of issues with that. So you had to recode things, you had to add public APIs for things that you before used reflection with. So this was mostly centered around that. JDK 17 was about the what the JDK team calls strong encapsulation. So this means that a lot of the SON types, the internal JDK types, are not longer accessible. So one of the worst offender there is probably SONMISC unsafe. So that's used a lot for things like proxies, manual memory allocation, some compare and swap things as well, so all the low level things. And yeah, some MISC unsafe is not there anymore, it's not accessible, so we had to find replacements for that. I think the EGB proxy code used that, so we had to create a new proxy thing for that. So this was somewhat hard, but in the end doable. Most regular applications might not use this too much. It's more of a server thing to use, or a low-level software thing to use. So now we move to JDK 18. And the major issue we're facing there is with the security manager. So for the ones who don't know, security manager is going to be deprecated. It is deprecated in JDK 17, but it will be removed. And in JDK 18, it starts throwing exceptions now. If you set your own custom security manager, you'll get a nice exception. And a security manager is used a lot for things you might not think of at first, like tools often use it to prevent another tool calling system.exit. So if you have a command line tool that's used by e.g. a Haven plugin or by Ant, what have you, then those tools it calls, they might call system.exit, and this would abort the entire build, which is of course not something you want. You just want an exception if something fails. So you can't set the security manager anymore, so you have to patch the code to not call system.exit. So that's what we did for a couple of those usages. But overall, this can be quite problematic. The bit database is one that uses the security manager quite intensively. So luckily they had a switch to not use it because they introduced it only a couple of versions ago. But otherwise it would be quite difficult to switch that off. So in general, what caused a lot of problems all the time is that the class file versions change. So like JDK 17 is version 61, I think. JDK 16 is version 60, and then the tool only knows, say, about version 16. So you have to update tools like ASM or ByteBuddy, what have you, to support the latest version. These are things like JPA, they use that. Quite a lot of other things. HK2 uses it too, I think. So typically, it's not that difficult to do, but of course, you have to do it. All right. So then, one of the other things we focused on for GlassFish at Eclipse was building and testing. So there's a lot of things there. We moved to Yay Unit 5. There's quite a lot of work. Removed as much as possible from test ng. Not that we're against test ng in any way, but you want to have a consistent build system and test system. So there were some tests for test ng, some were Yay Unit 5. So we made that a bit more consistent. And it will continue to do that. So watching the time, I have to hurry up a little bit. Okay, so let's briefly talk about GlassFish beyond the server. So there's things related to the components of GlassFish. So it's not only a server, the components are used quite a lot independently. And GlassFish is in some kind of family, so to speak. So we'll briefly take a look at that. So here we have a graph. It's of course not readable on the slide, but it shows which servers use which components. The orange ones are the Eclipse GlassFish ones, and you see they're used quite a bit. So the green one is Jakarta EE, by the way, which is the only one who uses components from a single vendor, although they do offer their own distributions from Tomy Tribe, and they do use other components. Okay, so quickly go for this one. So we see that Jersey and Mahara are used quite a lot. I hope the slide displays on the screen already, so it's a bit slow here. We see that another category of products, so Halidon, Drop Wizard, and Piranha Cloud, which are not EE servers or EE certified, but they do use a lot of GlassFish components. Okay, so one of the things that we're working on as well at GlassFish is splitting off new components. So we split off Exousia, which is Jakarta authorization, and we're going to split off two more things. So Ilias is going to be about Jakarta authentication, and Transact, it's not clear if that's going to be the final name, it's going to be Jakarta transactions split off. Okay, so we just mentioned that GlassFish is in an extended family. So we have Primetime, we have Fujitsu, Payara, and they're all based in certain ways on GlassFish. So GlassFish is not just a single server, but it's used by a lot of other parties as well. So very quickly about the ecosystem, we're preparing a Orkillian, or we have prepared already a new Orkillian connector. It has some extended features, so you can configure everything from your palm, and it has things like post-boot commands from within the Orkillian connector. We're going to add some new things as well for overriding jar files in your /modules folder, which is mostly used for TCK testing, but could be used by applications as well. Okay, so very quickly, since time is running out, GlassFish 7. We have recently moved our master branch to GlassFish 7. There's also some circular dependencies between GlassFish and Jersey. We have merged in the first PR with Jakarta EE 10 components.
Hi, Aryan. Sorry to cut you, but then thank you for the great session. But you know the time is up.
Yes, I was watching the time and racing.
Don't worry. Thank you so much, though.
Yeah.
Session. Thank you.
You're welcome. Okay, sorry for
we'll
not.
Share your presentation on the community folder later on, so everyone can access that. Thank you so much.
All right. All right. Thank you for having me.
Thank you. Bye.